We have a quiz we've been working on, so let's just work through these problems. So we have 2x squared squared. Well, that equals 2 squared times x squared squared. And I think it's important to write out that step rather than just doing it in your head. If you do it in your head and don't write out the step, then when you get something a little unfamiliar, you're not going to know what to do with it. Okay? Or you might not know what to do with it. 2 squared is 4. And this is then x to the 2 multiplied by 2. And you want to write that out, which is 4x to the 4th. Now, if you've done a lot of these and you think you understand the rules, it's still a little dangerous to bypass them. I recommend when you do the homework that you always write out all the steps so that you reinforce them, so you get to a test and you know what to do. Now, this won't be on the test that's due next week, okay? But it's going to be in the exam, final exam. So make sure you really reinforce these rules in the way you write out your solutions, okay? Then we have 5x squared y cubed. What's that equal? That's 5 cubed times x squared cubed times y cubed. 5 cubed is 125. X squared cubed is x to the 2 times 3. And y cubed is y to the 3 times 3. So that's 125 x to the 6th, y to the 9th. Then you look back if you want to. You're going to raise to the 3rd power, so you're going to multiply all these powers by 3. You're going to get 3 times 2 gives you 6, 3 times 3 gives you 9. That works. But here are the details, the nuts and bolts of why it works. We have 12 x to the 5th, y to the 8th, divided by 2x cubed, y to the 5th. All that raised to the 2nd power. And what in the world is that? Well, first, you have options. You can square every term here in the numerator and in the denominator, or you can simplify this expression. This equals 12 over 2 times x to the 5th over x to the 3rd times y to the 8th over y to the 5th. And then we square it. Well, 12 over 2 is 6. X to the 5th over x to the 3rd is x to the 5 minus 3. Y to the 8th over y to the 5th is y to the 8 minus 5. And that's going to get squared. Well, that gives us then 6x, 5 minus 3 is 2. Y to the 8 minus 5, which is 3, squared. And now it's pretty easy. It's 6 squared times x squared times y cubed. X squared times y cubed squared. Be careful, like I'm not. Okay, 6 squared is 36. X squared is x to the 2 times 2. Y cubed squared is y to the 3 times 2. That comes out 36 x to the 4th, y to the 6th. Now, you could have also done it by, making this into 144 x to the 10th, y to the 16th over 4 x to the 6th, y to the 10th. It would have come out the same, but it's a little easier to simplify inside the parentheses before you square it. So I recommend that you do it that way. But if you do it the other way, it's certainly not wrong. Okay, well, the last one, this is going to lead us into one of our topics for today. It's x squared y cubed divided by x to the fifth y to the sixth. Well, that equals x squared over x to the fifth multiplied by y cubed over y to the sixth. Now, why does it equal this? Why can we separate it out like that? Well, because if we multiply the numerators, here x squared times y cubed, we get exactly the numerator of the original expression. If we multiply the denominators, we get x to the fifth, y to the sixth. So we know that it's safe to break it down like this. Then we have x to the 2 minus 5, y to the 3 minus 6, which is then x to the negative third, y to the negative third. What do we mean by x to the negative third and y to the negative third? We haven't seen that. So let's illustrate. Let's take this expression here. I'm just going to write out all the x's and all the y's. Now it's going to get a little long in the denominator. Okay, I've got them all in there. I had to write them pretty small, but you understand what I wrote. I wrote 6 y's here and I wrote 5 x's here with a dot between them to indicate multiplication. And up here, x squared is x times x. Now, normally we don't want to do this, although we want to think this. If I give you something like x to the 400th power and y to the 900th power, you're not going to write them all out. You're going to want to use the rules. But if I do this, I see that I could write this as x times x over x times x multiplied by 1 over x times x times x. We agree that if I multiply the numerators out, I get x times x, which is x squared. And if I multiply the denominators out, there are 5 x's in there. That's going to give me my x to the fifth. It's going to have 5 x's. Okay, so I can do that. Now you might wonder why I'm doing that, but I'm going to show you here in a minute. And then I can take all the y's in my numerator, with those over 3 of the y's in the denominator. And I'm left with 3 more y's. I got 1, 2, 3, 4, 5, 6. Might not be able to see them real well, but you know they're there. Okay. Again, if I multiply the numerators, I get x squared and I get y cubed. I multiply the denominators, I've got 5 x's, so I get x to the fifth. I multiply the denominators here, then I get 6 y's, I get y to the sixth. So everything is the same. But of course, this equals x times x over x times x is just 1. One over x times x times x is 1 over x cubed. With y's, give me 1. And then I get 1 over y cubed because I got 1 over y times y times y. And the ones don't change anything. This tells me I have 1 over x cubed y cubed. So every step of that is a pretty easy step. It's just maybe not totally clear why I made those steps, but I'm going to make that clear. I've got 1 over x cubed y cubed, and I've got x to the negative 3, y to the negative 3. They're both equal to the original expression. The original expression is the same in both cases, so this has to be equal to this. So we could write x to the negative 3, y to the negative 3. Equals 1 over x cubed y cubed. But whether you totally follow every step of what I've done, believe it, x to the negative 3 then means 1 over x cubed, and y to the negative 3 means 1 over y cubed. So we have a new rule. Scams. I don't think anybody's bumped it or anything, but okay. So now we can see what I'm going to write here. Rule. X to the negative a equals 1 over x to the a. And what we've done here is we've proven the rule. We've proven that x to the negative 3, y to the negative 3 is 1 over x cubed, y cubed. So the rule makes perfect sense. And I'm not going to give you an abstract proof of the rule. I could, but I'll just accept the rule and see what we can do with it. So let's try this. Let's ask you to simplify. X to the 4th, y to the 7th over x to the 7th, y cubed. And say simplify this, try to simplify it so you can write it out without a denominator. If you can't, then just simplify it, and it's real easy to see how you can do that with no denominator. I'll give you another one too. Simplify with no negative exponents. Let's make this one x to the 6th, y to the 12th over x to the 4th, y to the 15th. So go ahead and work on those for a minute, and I'll see how you're doing. And then we'll see what we can make of this. Okay. So what can we do with these? Again, If you believe what I've written down here, x to the negative third, y to the negative third has to equal 1 over x cubed, y cubed. Because if we simplify this expression one way, we get x to the negative third, y to the negative third. If we simplify the same expression another way, we get 1 over x to the third, y to the third. Now, this would be how we'd write this simplification without negative exponents. Okay? This is how we write it without denominators. We just take anything in the denominator and make its exponent negative and put it in the numerator. So let's see how that works out. So we make this rule. This rule looks like it ought to work in terms of the example we just did. So we got x to the fourth, y to the seventh, over x to the seventh, y cubed. That equals x to the 4 minus 7, y to the 7 minus 4, which equals x to the negative third, y to the third. Well, there it is, and there's no denominator. Now, if we wanted to simplify it with no negative exponents, well, let's write that here. We're going to do exactly the same thing. We've got x to the 6th, y to the 12th, over x to the 4th, y to the 15th. That equals x to x, y to the 6 minus 4, y to the 12 minus 15, which equals x to the second, y to the negative third, but we don't want negative exponents. That's okay. We can write this as x squared over y cubed. Or let's not skip a step here, as I keep telling you. Let's write out the intermediate step to make sure we understand. We have x squared multiplied by 1 over y cubed, which equals then x squared over y cubed. And we can even put that x squared over 1. So we're following the rule to multiply numerators and multiply denominators. Give this thing a denominator that doesn't change it. And there we have it. So if you understand, you're going to have problems on exponents that ask you to do this sort of thing. And right there it is. So let's just do a couple more. Then we want to take a look at scientific notation. This will be sufficient. Okay. And try to write out every step. Yeah. Okay, let's see. Gonna have x to the 6, y to the 5th, and c, I don't know. And you're gonna have x to the 6, so I don't know what that is. All it up. Next one is yeah, don't write the 0, that's the 0. Yeah, that's okay, that's okay. Yeah. Sure. Oh. Yeah. Does that just? It's going that. X of 0 is just one. Any number with 0 or 1. Okay. I'll explain that in a minute. Okay. Now if we write out every step. Oh, and I was still recording, wasn't I? Well, there's dead space in this recording. Now we have to do the exponents in the numerator and in the denominator. We can't just divide x squared by x cubed because the x squared is raised to a different power than the x cubed is. So x squared cubed is x to the 2 times 3. Y to the 5th to the 3rd is y to the 5 times 3. Z to the 7th to the 3rd is z to the 7 times 3. That's going to be over x to the 3 times 2 and y to the 3 times 3 and z to the 2 times 2. That's going to equal x to the 6th, y to the 15th, z to the 21, divided by x to the 6th, y to the 9th, z to the 4th. I'll be really meticulous here. And I'm going to write x to the 6th over x to the 6th, y to the 15th over y to the 9th, z to the 21st over z to the 4th. That equals x to the 0, y to the 6th, z to the 17th. Now, what is x to the 0? Actually, I have another step I should write here. It is going to be x to the 0, but it's x to the 6 minus 6, y to the 15 minus 9, z to the 21 minus 4, which is then what I wrote before, x to the 0, y to the 6th, z to the 17th. One thing now that I'll point out is that x to the 6 minus 6 is the same as x to the 0, obviously. But that's what we got from x to the 6th divided by x to the 6th. What's x to the 6th divided by x to the 6th? It's 1, right? Divide something by itself, you get 1. So this just equals 1 y to the 6th, z to the 17th, which is just y to the 6th, z to the 17th. And what we get from this is that x to the 0 is 1. It doesn't matter what x is. To get x to the 0, we can divide x to the 6th by x to the 6th. Okay? And that gives x to the 6 minus 6, which is x to the 0. We conclude that x to the 0 equals 1 no matter what x is. So here's another rule. X to the 0 equals 1. Any number to the 0 power equals 1. Try this. Okay, again, I recommend that you do these writing out every step so you reinforce the steps. But what you're going to get, x cubed squared is x to the 6th. Y cubed squared is y to the 3 times 2, which is y to the 6th. Z squared squared is z to the 2 times 2, which is z to the 4th. In the denominator, you're going to get x squared cubed, which is x to the 2 times 3, x to the 6th. Y to the 5 times 3 is y to the 15th. Z to the 7 times 3 is z to the 21, which equals then x to the 6 minus 6, y to the 6 minus 15, z to the 4 minus 21, which is x to the 0, y to the negative 15, z to the negative 17. And that's 1 times y to the negative 15, z to the negative 17, which is just y to the negative 15, z to the negative 17. And that's 1 over y to the 15, z to the 17. And just another example. And I don't think you're going to have too much trouble with this if you practice. Especially, I keep urging you write out every step you possibly can, because sometimes you're going to see stuff later where these things get a little weirder. And if you're not completely aware of the steps, you're likely to get confused. Okay, now the last couple of steps down here and down here might not have shown because what I'm seeing on my screen, the camera might have been aimed too high, but it hasn't been changed. And it was aimed too high. I don't know what's going on. Anyhow, down here again, we saw that x to the 6th over x to the 6th simplifies to x to the 6 minus 6, which is x to the 0. And of course, that's equal to x to the 6th over x to the 6th, and this is just 1. That's where we conclude that x to the 0 has to equal 1, and it doesn't matter what x is. x to the 0 equals 1. Okay? Because x of 0 is x to the 6 over x to the 6, which is x to the 6 minus 6. And this is 1. Okay, the last step here, I think we got this step. And then it's pretty obvious that 1 times y to the minus 15th z to the minus 17th is just y to the minus 15th z to the negative 17th, and that that's 1 over y to the 15th z to the 17th. You know, that thing with the camera might have just happened when I changed the. A little more. Okay, I want to talk about scientific notation. Let's just take a number like 357. You should be aware, I hope you are, that if you multiply by 100, it moves your decimal place over 2 units. Okay? If you're not aware of that, it's probably the fault of our curriculum, but that's a rule that you should be familiar with. If you aren't, need to get familiar with it. It's not a difficult rule. There are good reasons for it. I could explain the reasons, but we're going to leave it at this. If I multiply by 100, I've got to take that decimal and move it over 2 units, and that would give me 357. Okay? That equals 3.57 times 10 squared. 10 squared is 100. And this number is now in scientific notation. This number is between 1 and 10. And ten squared is a power of 10. So let's see if you could write 5,230 in scientific notation. That would be a number between 0 and 10, or between 1 and 10, and a power of 10. Okay, that was good. Everybody got it. The number has to be between 0 and 10, so we're going to have to put a decimal between the 5 and the 2. And it depends on whether you think the 0 is significant or not. If the 0 is significant, you include it, but I'm not going to belabor that point. Now, what would you have to multiply this by? What power of 10 would you multiply this by? Well, to get from this number to this number, I'd have to take the decimal and move it over 1, 2, 3 places, right? Which means that I'm going to have 10 to the third. Okay, so that's very good. Okay, now let's try multiplying this out. Now, here I'm going to end up having to multiply 3.57 by 5.23, and we don't want to bother with a calculator. Okay, so we're just going to write this as 3.57 times 5.23. We have a bunch of things that are multiplied, 4 quantities that are multiplied. We can multiply them in any order. So I've chosen to multiply the two numbers between 1 and 10 together. And then I'm going to multiply 10 to the second by 10 to the third. Now, 3.5 times 5 is 17.5. This is a little more than 3.5. This is a little more than 5. So I'm going to say this is approximately equal to 18. And I multiply these two numbers. What do I get if I multiply 10 to the second by 10 to the third? Finish this for me. What we now get, this is 18. We still have our 10 to the second times 10 to the third. (18) times 10 to the fifth. Okay, is this in scientific notation? No, because the number in front has to be between 1 and 10. So what do we do about that? Well, 18 is 1.8 times 10 to the 1. And we still got our 10 to the fifth. 10 to the 1 times 10 to the fifth is 1.8, well, 1.8 times 10 to the 1 times 10 to the fifth is 1.8 times 10 to the 1 plus 5, adding the exponents because I'm multiplying the numbers. And that's 1.8 times 10 to the sixth. Now, of course, 10 to the sixth is a million. So that's 1.8 times a million. So we can come back here and we can write got one too many zeros there. That's right. I write my commas in there, it's okay. 1,800,000. And that's right. Okay. I'm blind looking at my zeros. Okay, 1.8 times a million, 1.8 million, or 1,800,000. What about 7.2 times 10 to the 7th divided by 1.8 times 10 to the 10th? Now, that's a division sign, so you could write that as 7.2 times 10 to the 7th over 1.8 times 10 to the 10th. So what are you going to do with that? You're getting these, you're doing a good job on these, but just try to get every twist and turn into the process. Okay, now if you're having a little trouble, it's probably because you're not used to writing out all your steps. What are the steps here? The steps are write out your numbers like this, and then write out your powers of 10 like this. It's like they were X's and Y's. Okay? So when I say get used to writing out the steps, there's a reason for it, because right here is an example. This doesn't look exactly like an expression with a bunch of X's and Y's, but the same principle holds. 7.2 divided by 1.8 is 4. 10 to the 7th divided by 10 to the 10th is 10 to the 7 minus 10, which is 10 to the minus third. Or if you prefer, that comes out 0.004. Okay. So you have two assignments, one due over the weekend, one due Sunday, I believe. Open Math should clarify anything that you need to clarify and give you just a little more information.